Today we are starting Unit 4 with dot plots and histograms. A DH, also known as a designated hitter, is a player who plays on offense but not on defense, usually replacing the pitcher in the batting order. A numerical variable is a possible outcome that takes on a numerical value. A distribution is a variable identifies the possible outcomes of a variable and how often it takes those outcomes. A histogram is a graph which divides the values of a numerical variable into classes and uses bars to represent the number of values in each class. Frequency is the number of observations in each class. Relative frequency is a graph which shows the proportion or percentage of observations in each class rather than the number of observations. Here are the run totals for the 14 American League teams and the 16 National League teams for 2008. Currently, there are 15 teams in each division. Houston Astros are now an American League team. Make a dot plot comparing the distributions of the runs scored for the American League and the National League teams in 2008. So I have done that below. So an easy way to make a histogram from the number of runs scored is to start with your dot plot and make sure when you make your dot plot that you have labels for your axes. Then you'll divide it into 5 to 10 equally wide classes. Count how many observations are in each class. Draw bars because they have to be equally wide unless they have no observations. And the height corresponds to how many are in each class. So in this case, we would have 4. This one would be 2. This one would be 7. This one would be 10, 5, 1, 1 for overall. So then what we would do is we would make a histogram. So my frequency I'm going to count by 2s. You can just label that frequency. And then down here for the number of runs, I'm going to start with 600. And I'm going to count by 50s because that's what I used on my dot plot. So then we had 4 between 600 and 650. We had 2 between 650 and 700. Then we had 7 between 700 and 750. 10 between 750 and 800. 5 between 800 and 850. Then 1 for each of the next 2. Okay, so that would be our histogram. Our relative frequency histogram is going to be pretty much the same, except over here we're going to have the proportions. So I'm going to do I'm going to count by 5/100ths. And I will label this relative frequency. Then the bottom is the same. So to get your relative frequency, you're going to take your number, so in this case 4, and divide it by the total, which is 30. And I'm going to come up with 0.13. Obviously, I've got 0.15, not 0.13, so just get as close as possible. It doesn't have to be perfect. And keep going. So 2 divided by 30 for the next set, so that's 0.7. Then I have 7, which is 0.23. Then 10, which you should know is 0.33. Then we had 5, which is 0.17. And then 1 twice. So that's 0.3 and 0.3. So you notice it has the same shape. It looks the same. The difference would only be the vertical axis. And make sure you label your axes. Using a relative frequency histograms is especially useful when you're comparing distributions that have different numbers of observations. So for instance, these histograms compare the points scored by the Lakers and by everyone else in the 2008-2009 season. It makes it seem like the Lakers didn't score anything, that they played really bad. But if you look on a relative frequency histogram, you'll notice it makes a lot more sense. You can see that the Lakers did in fact score with similar percentages in some places and higher in others when you make a relative frequency histogram.